Disclaimer: this podcast is for informational purposes only and should not be considered medical advice. Always consult a qualified healthcare professional before making decisions about peptides, medications, or health treatments. Today we are diving into angiotensin peptides. These are small fragments of protein that come from a larger precursor called angiotensinogen, which is produced in the liver. Angiotensin peptides are a crucial part of what is known as the renin-angiotensin system. This system helps regulate blood pressure, fluid balance, and electrolyte levels throughout the body. The process begins when the kidneys release an enzyme called renin. Renin acts on angiotensinogen to produce angiotensin 1. Angiotensin 1 on its own does not do much, but it is converted by another enzyme called angiotensin converting enzyme into angiotensin 2. Angiotensin 2 is a powerful molecule that narrows blood vessels, increases blood pressure, and stimulates the release of hormones like aldosterone that control salt and water retention. Beyond angiotensin 2, there are other related fragments, such as angiotensin 3 and angiotensin 4. Angiotensin 3 can also raise blood pressure and stimulate aldosterone release, while angiotensin 4 has been studied for potential effects on memory, cognition, and even blood flow regulation. So these peptides act like a whole family, each with unique roles. One reason angiotensin peptides are so important is that they provide multiple points of control for the body to adjust. Circulation if blood pressure is too low, the system can tighten vessels and conserve water. If it is too high, medications can be used to block certain steps. This is why angiotensin is central to treatments for hypertension, heart failure, and kidney disease. For example, angiotensin converting enzyme inhibitors stop the conversion of angiotensin 1 to angiotensin 2, lowering blood pressure. Angiotensin receptor blockers also prevent angiotensin 2 from binding to its target receptors. Interestingly, angiotensin peptides are not only about blood pressure. Recent research suggests they may influence inflammation, metabolism, and even neurological processes in the brain. For example, the angiotensin 4 fragment has been explored in relation to memory function and potential therapeutic effects in cognitive decline. This highlights how peptides that were once seen only in cardiovascular regulation might also be connected to broader areas of health. Scientists are now studying new therapeutic peptides that mimic or block parts of the angiotensin system with more precision than traditional drugs. The idea is to develop molecules that can fine-tune responses, reducing side effects while keeping beneficial effects intact. The complexity of the renin-angiotensin system makes it both a challenge and an opportunity for peptide-based medicine. Another fascinating angle is how angiotensin peptides interact with exercise and stress during physical activity. The body needs to balance blood flow to muscles while maintaining adequate blood pressure. Angiotensin peptides help manage this delicate balance by adjusting vessel tone and hormone release under chronic stress or illness. The system can become overactive, contributing to high blood pressure or organ damage, so therapies targeting these peptides can restore balance. To summarize, angiotensin peptides are more than just regulators of blood pressure. They are part of a sophisticated signaling network that affects the heart, kidneys, brain, and overall fluid balance. The more we learn about them, the more opportunities we see for precise therapies that may go beyond cardiovascular health alone. Disclaimer: this podcast is for informational purposes only and should not be considered medical advice. Always consult a qualified healthcare professional before making decisions about peptides, medications, or health treatments. Thanks for listening. Keep learning and stay curious.